Okay, we are going to look at the converse of the Pythagorean theorem. So the converse of the Pythagorean theorem states that if a triangle with side lengths A, B, and C has the property that a squared plus b squared equals c squared, then it is a right triangle. So we want to figure out, given side lengths, is it right? Okay, because of the Pythagorean converse, we can check whether a triangle is right or not. Consider the following triangles. If their side lengths make the Pythagorean theorem true, they are right. Remember, the longest side is going to be the hypotenuse. So whatever the longest length is needs to be the hypotenuse. Okay, so in example 1, we see the longest side is 17. So when we set up our Pythagorean theorem, 17 is going to be on the side by itself. All right, so we take our Pythagorean theorem, which is a squared plus b squared equals c squared, and we're going to substitute in our sides. So our shorter legs, or our two legs, 8 squared and 15 squared equals 17 squared. In our next step, we're going to go ahead and square each of those numbers. We can't just get rid of the squares, right? We're going to follow order of operations. We need to square those numbers. So we get 64 plus 225 equals 289. And then we're going to simplify. 64 plus 225 is 289. 17 squared was 289. Right, so when we simplify each side, we get their equal. It is a right triangle. In example 2, again, we're going to look for that longest side. Our longest side here is 7. So that's going to go on one side by itself. And then we're going to take 2 squared and 5 squared, the legs. We're going to square each of them. 2 squared is 4, 5 squared is 25. And then the other side, we have our hypotenuse squared, which is 7. 7 squared is 49. So we're going to simplify. 4 plus 25 is 29. On the other side, we have 49. These are not equal, so we know that this is not a right triangle. So let's take a look at these. All right, so number 1, my longest side is 34. Okay, so that's going to be my hypotenuse. So I start with my Pythagorean theorem, a squared plus b squared equals c squared. Then I'm going to go ahead and substitute in place of a, 16, in place of b, 30, and in place of c, 34. And then I'm going to go ahead and square each of those numbers. So 16 squared is 256, 30 squared is 900, and 34 squared is 1,156. My next step would be to combine. On the left, 256 plus 900 is 1,156. On the right, I get 1,156. They are equal, so we know that this is a right triangle. Number 2, again, I'm looking for my longest side. My longest side is here. This is going to be my hypotenuse. So I'm going to take my Pythagorean theorem, a squared plus b squared equals c squared, and I'm going to substitute my numbers in. So a and b are my legs. I'm going to do 25 squared plus 31 squared equals 37 squared. My next step, I'm going to go ahead and square each of these numbers. So 25 squared is 625, 31 squared is 961, and 37 squared is 1,369. If I add the two numbers together on the left, I get 1,586. That does not equal 1,369, so this is not a right triangle. Okay, go ahead and pause, try the last two, and then when you're ready, come on back. Okay, for the next one, we have a squared plus b squared equals c squared. Our longest length is 25. I'm going to just take the units out and just work with the numbers here. 17 squared is 289. 24 squared is 576. 25 squared is 625. When I add those together, 289 plus 576 gives me 865. That does not equal 625, so this is not a right triangle. Number 4, I'm going to take my Pythagorean theorem, a squared plus c squared equals c squared. Go ahead and substitute each number in. I'm going to square each of these numbers. I'm going to simplify the left, and I get 25 equals 25. This is true, so that this is a right triangle. So if you simplify and you get the two sides to be equal, it is a right triangle. If you simplify and the numbers are not equivalent, then we know we do not have a right triangle.